Chapters 12.2 and 12.4, the circle and the ellipse. Just so you know, the textbook does not address circles itself, but mainly refers to them as an ellipse with eccentricity of 0. But on these notes, we're going to do both. So my first question is, how do we typically express the size of a circle? And when we do that, it's usually by the radius, known as r, and even we could say the diameter, which is 2 times the radius. So, looking at the standard equation of a circle, the center is known as HK and the radius called r. So, our equation is x minus h squared plus y minus k squared equals r squared. So let's practice writing the standard equation of a circle. Okay, so number 1 gives us a radius of 5 and a center of 2. So this center is h and k, and then r is 5. So we have x minus 2 squared plus y minus 1 squared is equal to r squared, so we can say 5 squared. All right, so number 2, negative 3 is h and 4 is k. Now, we have a negative now, so we're going to keep the same equation, x minus negative 3 squared plus y minus 4 squared is equal to the radius 4 squared. So when we simplify that, this is why we're going to have x plus 3 squared, and then the rest stays the same. So whenever you see a plus, you now understand that it's because we inputted in a negative value. Okay, so if we have a center at 0, 0, that's my h, that's my k, then we have x minus 0 squared plus y minus 0 squared is equal to 3 squared. And yes, we do simplify this into x squared plus y squared equal to 3 squared. Okay, so now we're going to identify the center and the radius if we were given an equation. So, for number 4, since I have x squared and y squared, just like we finished in number 3, that means our center is going to be at 0, 0. So then we have the radius. So let's find the radius. Now, up above, we were squaring that last value and writing it as, 5 squared. So if I was given 25, to go backwards, I'm going to take the square root and get my r value of 5. And then the last thing we do need to identify is the diameter. And you'll see why in a second when we graph. So the diameter is twice the radius, so we have a diameter of 10. Okay, so when we go to graph, we have a center at 0, 0. So from 0, 0, we have a radius of 5. So we're going to go to the right, up, left, and down 5 units. So to the right, we are at the point 5, 0. When we go up, we're at the point 0, 5. To the left, it's negative 5, 0, and down is 0, negative 5. So then I connect it and make my circle. And something we can check at the end is that we have a diameter of 10. So if I go from -5 all the way to the +5, that is 10 units. So this is my graph. Okay, so for this next one, we're going to have a center at 3, 0. My radius is going to be the square root of 9, which is 3, which means that my diameter is going to be 6. Okay, so let's graph. All right, so I'm going to first start with my center, which is at 3, 0. And then from that point out, I'm going to go 3 on to the left, right, up, and down. So I have a point at 6, 0. I have a point at 3, 3. I have a point at the origin. And then I have a point at 3, -3. And when we double check, our diameter from the origin over to 6, 0 is 6 units. So this is our graph of our circle. Okay, and then for number 6, we are going to have a center, taking it from the equation all the way up to the top, h, k, of 3, -2, because this plus came about because we plugged in a -2 value in front of or behind a minus sign. My radius is the square root of 16, which is 4. And then my diameter is twice my radius, so I have a diameter of 8. Okay, so when I graph, I'm going to start at 3, -2 as my center. And then I'm going to go 4 units to the right, up, left, and down. So I have a point here at 7, -2. Above it, I have a point at 3, 2. Next to it, -1, -2. And then below it, I have a point of 3, -6. And once again, my diameter is a value of 8. So this is how we graph circles. Okay, so now we're going to talk about graphing an ellipse. And this, is an ellipse, is like your oval shape. So we have 2 equations up at the top. The numerators are both the same. They're both set equal to 1, but we have a difference in where a or b squared will be. Okay, so something that we're going to note right now, and I will explain further in 1 second, is the fact that since we have a and b in 2 different positions for those equations, then we will have 2 different kind of ellipses. There will be an ellipse that has a longer width than height, and then there will be ellipses that have a longer height than width. So in both cases, A is always going to be greater than B. Therefore, A is always the length of the semi-major axis, okay? Now, a couple of things to point out is it's the length of the semi-major axis, and then the fact that it says major axis. Okay, so what does this mean? When we, right here in this box, we have c squared equals a squared minus b squared, and E equals C over A. Now, this E stands for eccentricity. And what does that do? Eccentricity defines the shape, how it spins. Okay, how these ovals, or these ellipses are created. So if we're looking at the horizontal major axis, so that equation up top on the left goes with the horizontal major axis because A, which is greater than B, is underneath, it's in the denominator of H, and H is our horizontal shift, if you will, our left and right, and defines the X value in our center. So if A is greater than B, then that's why we have our left and our right axes bigger than our up and down axes. So right here, this is called the major axis. And we know it's the major one versus our vertical, which is our minor, because A is underneath the H value and H is right here, the X, okay? So up top I said A is always the length of the semi-major. So when we semi meaning like a semicircle half, right here we have the semi-major length, okay? And when you look at this point over here, at H we subtract A, and then at H on the right, we add A. So A is just the length of the semi-major. You multiply it by 2, then it gives you the length of the whole major axis. So going off that one more time, down here is a box that says the length of the major axis is 2 times the A value, and length of the minor is 2 times the B value. Okay, and then we have this value, the focus. This focus is halfway. I'm sorry, it's not halfway. The focus is C units from your center only on the major axis. So my major axis here is the left and right side, right here, horizontally, my major. And so that's why we have a focus on it. Now the focus is the C value. Well, this comes from this equation, C squared equals A squared minus B squared. So we will have to do a little solving to figure that out. Okay, so let's fill out this vertical major axis. Okay, so started by adding in my minor and major axis. Now, my major axis is the longer one, so my major axis is going vertically. And my minor axis is going horizontally. So in the middle we have our center, which is labeled H, K. So over here on the right of the minor axis, we are going to do the H value, so from the center, H plus whatever our B is, because remember, B is the length of the minor axis, comma, my K value. And then over here on the left, we have H minus B, and then my k value as a point. For the major axis, we know that it's going to be A. So down here, we have h comma k minus A. And above, we're going to have h comma k plus A. And the last thing to label is going to be my focus, which is only on the major axis. Okay, so let's say it's right here. We have the h value, but then it affects k, since we're on the k axis, if you will, the vertical axis, k plus c. And then down here we have h comma k minus c. Okay, so that was a lot of information, so let's see if we can graph and kind of make sense of some of this. So we're going to sketch the graph, we're going to identify all the features, we're going to identify the center, the vertices, endpoints of the major or minor axis, and focus. Okay, so the first thing we need to be able to do is identify A and B. Now remember, in our equation, A and B, it said A squared and B squared. So just like when we were doing the radius on the previous examples, A is going to be the square root of 36, and B is going to be the square root of 4, which is 2. Now, I know A, I went straight to 36 because it's always the value greater than the other one. So I know that that's always going to be A, whichever one is bigger. So the next thing that we can do is find the center, and looking at the numerator, we can depict that the center, there's no shifts, so our center is 0, 0. And something else that's important to note is that we have is the major axis. So based off of A and K, which one is going to be the major? Well, since 36 is greater than 4, it's under the Y value, and when you think Y, you think vertical. So our vertical axis is going to be our major axis. And then the last thing is we have to find C, because C is the value of our focus, or part of our focus. So C squared equals A squared minus B squared, but remember, A and B are already squared in this problem, so we have 36 minus 4. And we want to, it will always be a positive value because we need to take the square root of it, and A is always going to come first, which we always know is the greater value. So C equals the square root of 32, and that's how we're going to leave it. Okay, so let's graph. Okay, so I'm first going to start by labeling my center, which is at 0, 0. Now, the value of my vertical axis is my major one. I'm going to go up and down the value of A, because remember, A is the semi-major, so 2A is the whole diameter. So I need to have a diameter of 12, meaning from 0, 0, I'm going to go up to 6. And I'm going to go down -6. B is our minor axis. B's value is 2. So from 0, 0, we're going to go 2 to the right and 2 to the left. All right, so I'm going to actually draw it first, and then we're going to come back and do our focus. So here we have, oh, that was a bad one. Okay, our ellipse. Trying to make it as even There we have it. Okay, now our focus is going to be, since it's only on the major axis, it's going to be, we're going to go up and down the value of 32, so, or root 32, which root 32 is 5.66, so we're going to estimate that. 2, 3, 4, 5, so almost to 6. Right here is my focus. So I have 0, comma, root 32. And down here is the negative version of that. 0, comma, negative root 32. And we just label that point and that's it. We're not going to do anything else or connect any other lines with that. So there's our ellipse for the first problem. Okay, so for number 2, our a value is going to be the square root of 49. So we have an a value of 7 because it's the greater value. Our b value is going to be 6. Then my center is going to be 0 because it's just x squared. And then it says y minus 1, so 0, comma 1 is my center. Now, since a came from root 49, and that was under the x value in our original equation, we have a horizontal major axis. And then for our c value, we have c squared is going to equal 49 minus 36, which is 13. So c equals the square root of 13. And the square root of 13, just to estimate it now, if you will, is going to be about 3.6. So this right here I just did so that when we graph it, we already know it. But we are going to keep it in the exact form of square root of 13 because I did round to get 3.6. Okay, so we're going to start with our center at 0, comma 1. Now, my a value is going to take me to the left and right because it's a horizontal major axis. So I'm going to go to the right. From the center, I'm going to go to the right 7. And then I'm going to go to the left 7. Our b value is 6, so from the center, I'm going to go up 6. And then I'm going to go from the center down 6, which puts me at 0, comma, negative 5. Okay, so now we can connect. And this one, since the a and b values are just 1, have a difference of 1, it's going to kind of almost look like a circle, where the circle has the same radius all the way around. But we do know that the horizontal axis is going to be a little bit wider. So something like that. And then my focus is going to be on my horizontal axis. From the center, I'm going to go over about 3.6. But I'm going to label it root 13, comma 1, because that's where I am on the graph. And over here I have negative root 13, comma 1. Okay, so number 3. We are going to start with our a value, which is the greater of the two. So from 25, I'm going to take the square root of that, and I know that a is going to be 5. Square root of 9 then gives me my b value of 3. And the numerator gives me my center, which is going to be at 4, comma, negative 3. Since we know that a is the major axis and it is underneath of y in my equation, I'm going to have another vertical major axis. And to find c to help me with the focus, I'm I'm going to have c squared is equal to 25 minus 9, which is 16, so c equals 4. All right, so my center, I'm going to start at my center at 4 comma negative 3. Starting with let's start with A, our vertical axis. I'm going to go up 5 from my center, which puts me at the value 4 comma 2. And my center was 4 comma negative 3. I'm going to go to the right, down 4, down 5. And unfortunately it goes off right here, so we're just going to put that there for now. It's not my favorite thing to happen, but just for now. And this is 4 comma negative 8. And now we're going to go left and right, and that's B. B is 3, so 1, 2, 3 to the right puts me at 7 comma negative 3. Sorry, I'm kind of squeezing those values in. And over here on the left, I have 1 comma negative 3. So when I connect, it looks more like it's stretched vertically because that's my major axis. And my focus is at 4, so from the center, I'm going to go up 4. I'm going to go up 4 for my center, which is 4 comma 1. And again, we're on the set. We're going up from the center 4 values because the focus is always on our major axis, which is vertical. So then we have this value down here, 4 comma negative 7. And there we have it. Okay, so in the last part of this lesson is if we are given an ellipse not in standard form. So standard form, remember, it was x squared and y squared and had a denominator. There was no other value up with x or y unless it was, x minus y or x plus y. X minus 1 or y plus 1 or something like that. But it was also always equal to 0. So that's the big thing that you're going to remember. If it's not equal to 0, it's not, if it's not equal to 1, it has to be equal to 1 for it to be in standard form. Sorry about that. So for this situation down at the bottom, we have 2 examples when they're not in standard form. So let's take a look at what we would do so that we could put them into standard form. Okay, so for this first one, like I said, it has to be equal to 1. So I'm going to go through and I'm going to divide each of these pieces by 144 because that is the way that I get it equal to 1. So now we simplify. 16 divided by 144 gives you 1 over 9. So that gives me x squared over 9. Minus 9 divided by 144 gives me 1 over 16, so we have y squared over 16 equal to 1. So now I can identify all my key features and graph this ellipse because it's in standard form. So for the second one, first off, the constant is on the wrong side, so we're going to add 49 to both sides to start. So now it's equal to 49 and not 1, so we're going to divide all of these fractions or pieces by 49. And then that's actually simplified for us. So we have x minus 1 squared over 49 plus y plus 4 squared over 49 equal to 1. So again, from here we can identify everything. And since we have the same a and b value, this one's going to be a true circle, whereas the one up in purple I have above is going to be an ellipse. Now, just also to note, everything can be called an ellipse, but when you have an ellipse that has the same a and b value, that's what creates our circle because the radius is constant all the way around.